Bismillahirrahmanirrahim. Dear students, here we have exercise from chapter 2, number theory. The first question is prove that if n is any odd integer, then 8 divides n square minus 1. The solution here is since n is any odd integer, then we can write n is equal to 2k plus 1, where k is some integer. Now squaring both sides, here we see the squaring. Now simplifying this square, we get this value. Now transposing this one to the left side, so this is the transposition. Now taking 4k common, here this is k plus 1, dividing this expression by 2 and multiplying by 2, so we get 8k, k into k plus 1 by 2. K into k plus 1 is even for all integer k, whether k is even or odd. Now from this equation we can write 8 divides n square minus 1 for all odd integers n. Here this k into k plus 1 is even. This even is divisible by 2 and the result will be integer. So here we have one integer equal to 8 times another integer, which gives us the expression 8 divides n square minus 1, where n is odd integer. Now we come to the next slide and we will solve the given problem by another method. So this is the same solution by another method, and here the statement of the problem is if n is odd, then 8 divides n square minus 1. The solution is since n is odd, then we can write any odd integer can be written as n is equal to 2k plus 1, where k is integer. Now taking this n square minus 1 and putting value of n, so here we see value of n. Simplifying, this is a simplification. This 1 and minus 1 will be cancelled and this will be the result. Taking 4k common, here we have k and k plus 1. Now this k may be either even or odd. This k is even or odd. So the first case, if k is even, then there is this k1 belong to z such that k is equal to 2k1. Every even integer can be expressed as k is equal to 2k1, where k1 is also integer. Now putting this value of k in this equation, so we get n square minus 1 is equal to 4 times 2k1 into 2k1 plus 1. यहाँ पे हमने k की वैल्यू 2k1 सब्स्टिट्यूट किया है, k की जगह 2k1 आ चुका है. Now this 2 and this 4 will be multiplied together. Now here we have this result. Since 8 divides 8, 8 को divide करता है और 8 times k1, 2k1 plus 8 को भी divide करता है. This 8 divides this expression, hence we can say that 8 divides n square minus 1, because this expression is equal to n square minus 1. Since 8 divides the right hand side, hence 8 will divide the left hand side. So this is the given problem for this k. If k is even, now we have to take the second case where this k will be odd, and then we have to show that whether 8 divides n square minus 1. So let's see in the next slide where if k is odd. The second case is if k is odd, then there exists an integer k2 such that k is equal to 2k2 plus 1. Now we have to put this value of k in the problem in the equation 1. Since k is odd, then value of k is equal to 2k2 plus 1. K is 2k2 plus 1, so putting value here. So here we will put 2k2 plus 1. Here we will get 2k2 plus 1. तो यहाँ से 2 कॉमन निकलेगा, यहाँ पे आएगा. तो देखते हैं. Since k is odd, so we can take k is equal to 2k2 plus 1. This is k, where f k is 2k2 plus 1। अब वो क्या करते हैं, इसी वैल्यू को हम इक्वेशन नंबर 1 में पुट करते हैं। तो n square minus 1 is equal to 4 times 2k2 plus 1 and 2k2 plus 1 plus 1। इक्वेशन नंबर 1 में हमने वैल्यू सब्स्टिट्यूट की। अब यहाँ हम क्या कर सकते हैं, 1 1 2 आएगा, यहाँ से हम 2 कॉमन निकालते हैं, इसी 2 को 4 के साथ मल्टीप्लाई करते हैं तो हमारे पास ये वाला रिजल्ट मिलता है। अब यहाँ पे क्या है, obviously a divide this integer and this integer is equal to n square minus 1, so a divide n square minus 1 for all odd integer। तो यहाँ पे हमने जो सेकंड मेथड अडॉप्ट किया उस पे हमने यहाँ पे जो प्रॉब्लम था, इक्वेशन था, फर्स्ट केस में हमने k लिया e1 2k1 यहाँ पे सब्स्टिट्यूट किया और ये रिजल्ट आ गया। सेकंड केस में हमने k को r लिया और हमने लिया k को 2k2 प्लस 1 यहाँ पे सब्स्टिट्यूट किया और हमने प्रूव किया कि 8 डिवाइड्स n स्क्वायर माइनस 1। तो n की वैल्यू अगर 8 हो तो 8 विल डिवाइड n स्क्वायर माइनस 1।